On me. Hello, I'm John Leeper. I'm presenting on behalf of my colleagues Maximum and Maria, their husband-wife team out in Rendsburg, Germany for Haivision. I'm in San Diego. I'm more of a defense guy that's been doing transport stream delivery from drones for a couple decades now. When I'm talking about it's been interesting hearing this room talk more about the segment delivery of this wide, massive distribution. And the use cases that I've been focused on have been more of those quick, real-time, interactive steering sensors to be able to look at things and do fun things with what you see. So at Haivision, one of the things that we deal with a lot is still the broadcast modes of transport streams, and being able to deliver transport streams in broadcast scenarios. That's usually, we're going to throw TS packets, a certain number of them, over a UDP datagram to a very specific target. Or if we're using multicast, we can distribute to multiple targets simultaneously that want to adhere to or listen to those different multicast addresses. As you extend the distance between the source and the destination, you incur loss, you incur hops, and that becomes detrimental to some of these transport streams that get pushed over. So years ago, a group of folks at Haivision had put together this secure, reliable transport protocol called SRT to do sub-second latency for live contribution primarily. So this is a protocol, as Luke had suggested earlier, that you have to establish what you want your latency to be so that you can kind of get a gauge of what you preemptively know what you want your quality to be. So it allows you to do, on top of it, it really is focused on that transport. While it's typically used to be able to shove transport stream through it, it's agnostic to the data content that's beneath it. It does allow you for a bidirectional connection, secure encrypted connection that you can also add FEC to. You can have this variable loss that you want, so it's not a guaranteed delivery. If you start to send packets after a certain amount of time, they get dropped on the floor, and you keep churning on because you need to keep up with live. So there's other features of this protocol that have been used for connection bonding. So being able to use path redundancy over LTE networks, use multiple cellular connections to send to a receiver, and then the redundant packets get taken care of there. Again, content agnostic, and it's open source. It's also based on the library. It can do there's a mode that can do guaranteed delivery. It's more of a file transfer mode, so it becomes a multi-trick pony. Actually, starting tomorrow, there's going to be an interop plug fest for folks that are interested. YouTube has been very interested in SRT and are going to start using this as a ingestion protocol for YouTube Live, which is kind of cool. If you're interested, there's you can join all this next week. So we've been talking about Quick this whole time. I'm the outlier talking about something more on the datagram side. So you've heard a couple mentions of the datagram here today, but mostly about streams and being able to establish your quick connection between your client and your server and start setting up multiple streams through that. There's also a mode for being able to use datagram. So to set you up here, what are we doing? We're thinking about leveraging, what can the algorithms that are in SRT that do the retransmission, that do FEC, how can they help protect some of the quick connection? Where quick could be used instead of like SRT being the encryption, quick can provide that sort of zero trust aspect between client and server, and SRT can be used to do the timing recovery from the datagrams. So here the concept is to tunnel SRT over these quick datagrams. So a single SRT packet would be encapsulated into a single datagram frame. Maxim had put together this internet draft that's linked here if you want more details from the slides later. More documents this approach that he took. So to do this quick proof of concept, the Fastly's Quickly library was used to as an interface by which the SRT packets can be put into. And one of Maxim's projects, the SRT X transmit, it's a testing utility that does UDP, TCP, SRT quick as different transport protocols between two SRT endpoints. And what this allowed is the ability to generate or synthesize a stream, whether or not it wants to be VBR or CBR, and be able to receive, route, and also simulate the transmission of different network undulations. So we saw the dude watching a video on his bike earlier, and he gets undulations for your network that way. This tool also has hooks in it to be able to mimic those types of bandwidth things, those bandwidth variations and jitter variations over time. The setup is where actually Maria was using her MacBook as the source in Rendsburg and transferring to one of our other offices in Madrid, Spain. And they were doing it over the Wi-Fi just to say like, hey, we want to establish that we're going to try to do this novel point-to-point connection. We want to use Quick. We want to use SRT on top of Quick. And we want to see what a CBR stream, so constant bit rate through this link does. So side by side, here we have two kind of test scenarios. The one on the left is the one where we're sending just quick datagrams with a specially constructed packet. And at the right bit rate, and then on the right, we're using that same packet, but through the SRT layer through Quick. So as moving through this, one of the things that was important as we're instrumenting this test is to have some way to be able to derive metrics. So Maxime had put together a recommendation on how you instrument being able to count the packet sequence number, group sequence number, different timestamps that are in there that are microseconds based. You have a monotonic clock and a few other things in there with a checksum to confirm that you have the right data. And then after that is the remaining payload. So this sort of test packet was partially what was generated at the top of each test scenario, whether or not it's going to go over quick datagrams by themselves, naked, or quick datagrams on SRT with this datagram here. Clear? Yeah. So there's two metrics that are being looked at here. There's one that the RFC 3550, which is a jitter metric, which has a little bit of averaging in that metric across 16 different packets. So it'll average the delay as you go through receive 16 packets. The other one is this delay factor, this time-stamped delay factor that is a little bit more instantaneous. It gives you like this instantaneous delay, latency, throughput kind of idea. I'll show you that in the next slide. There's also, as part of this test setup, those naked quick packets without any SRT were sent at the same time as sending the SRT packets between the 2 points. That way, the same undulations or the network, how it moved, would be captured for both test scenarios. And you'll note here that there's 4 experiments that my colleagues did, spanning multiple minutes at different latency values. And you see those latencies there. I see 400, 600, 800, and another 800 for a longer duration. You're like, what? Well, SRT is supposed to be a low latency protocol. Why are you, almost getting towards a second here? And I'll show you that in a minute. So this first is the naked quick datagrams. So the first thing that you'll see here is like, well, there's a periodicity in this data. Why are we seeing every about minute? Why are we seeing this sort of delay factor pop up on the left graph? So all of these different bumps that you see here are contribute to real hardware having real issues periodically. So. And they would hit up to almost 200 milliseconds in some instances, but the average sort of noise floor here for sending the CBR stream was just over like 50, 60 milliseconds. So you have a bunch of jitter on how you see a lot of jitter and then a lot of outliers that appear during the data set. And once you start to recover the received data, you can kind of see over time that you get this lumpy bandwidth, where sometimes at that periodicity of these like spikes and bumps from the data channel that we have. You also see that represented in the data that you're receiving. And of note, when we're just using the quick datagrams for sending these packets, there is some loss here. There's small factors, 1 in 100,000, 10,000. So there is some loss that's experienced between all of these different scenarios, and there's also some out of order packets that are also noted here. So just again, this is to show that we're pushing CBR data through this network. We're experiencing drops and abnormalities in the data stream, and this is kind of expected. So when we leverage SRT, we see a different periodicity of this, but the scale is much reduced. So the scale on the previous chart was on up to 300, 400 milliseconds. This is 8 microseconds. So the scale is much reduced. So this is, and you can see that in the green line here of the received packets. It's steady. It's that CBR stream that we wanted to receive. So that's great. We see that as we go from the different experiments of doing 400, 600 to then 800, we're going from some unrecovered packets, which were likely explained by these big spikes, right? When we get these big spikes and we're incurring some latency, we're incurring some buffer issues, and some packets are getting dropped. So in that same scenario, we'd expect that there would be some packets when you're not having a big latency buffer in the SRT protocol to absorb those. You would still see some loss. So if loss is intolerable, using a predefined latency of 800 milliseconds lets us achieve 100% packet reception through this 15-minute period. And just to show that it also worked for an hour, there were no lost packets, there were no out-of-order packets, so which is good. We're able to show here that from SRT is doing, from an algorithmic perspective, is doing what we expect it to do. It's retransmitting packets over the quick protocol. So good. Again, this is with, although FEC is available in SRT, it wasn't used here. This is just the kind of stock-tuned parameters for the SRT protocol to do your latency window, and then it's a little bit of bandwidth overhead, and that's it. So what I wanted to show on this slide is kind of the side-by-side comparison between the jitter factor that you see on the left with the big spikes, and still big spikes, but at a much reduced scale. So these are 8 microseconds, excuse me, and then this is 300 milliseconds. So the amount of jitter that you're seeing in the delay between packets when you're going through the SRT end-to-end block is much smaller. One last thing to note about the experiment is you can see the round trip time as between the sender and the receiver in this case. It bumps up to those same sort of delay factors that you see on the left here. You start to see those same sort of spikes, and the round trip time show up and measuring on what that looks like from the SRT side. Also, really, what does this mean? As we're moving forward on if we're comparing the blue here, which is the quick datagrams, the amount of sort of buffer that you would have to have for receiving this, including the outliers, there's about a 300 millisecond buffer to be able to receive all of the data that's being sent over this channel. In contrast, there's a couple outliers for just the SRT over quick, where it's under 50 milliseconds. So on the left here, you start to see the expanded view of just the SRT data, and you're in the the scale here is in milliseconds, and you're in like sub-milliseconds for the variability of the timing. The conclusion to really take out of that is if you're using SRT to be able to protect your end-to-end link, it gives you a much easier way to ensure that you get the timing on your receiver, which could be good for your decoders, whether you're in your browser or not. So really, what this demonstrated is that the algorithms in SRT are useful and could be implemented on top of Quick. Them or some from RIST or others, it demonstrates that there is a potential use case here for being able to protect the Quick data in a mode that isn't the streams mechanism or the media over Quick means. Whether or not that's a good idea, it's still up for debate for the standards track. So yeah.
Thank you.
What questions do you have?
Can you do it after? We are really